In this video we're looking at how to derive the three equations we have here, the first one being the equation for resistance in series and the second two being equations for resistance in parallel. And they all make use of Ohm's law to do what they're wanting to do to get to that point. So first of all, let's look at resistance in series, and I'm going to draw our circuit, and we'll have just two resistors, R1 and R2. A little bit rough in my circuit drawing, but there's R1, there's R2, and we want to consider the voltages. We've got the total voltage, the supply voltage, or the voltage in series, should be equal to voltage across 1 plus the voltage across 2. And from that we're going to, from that rule, that knowledge of voltages in a loop, adding up to the supply, or adding up to 0 if we take the supply as positive and any drops as negative. From that we're going to work out an expression for the series resistance. So we've got the current in the circuit is the same everywhere in the circuit, and as I said before, we know that the supply voltage is V1 plus V2. Now, taking Ohm's law, V equals I times R. For the supply voltage, it'll be I times by the total resistance of the circuit, because total supply equals total resistance, which is RS in this case, times by total current, which is the same as the current anywhere in the circuit. And that equals V1. V1 equals I times R1, because it's the same current going through that resistor, and plus V2 is I times R2. And I think you can see where this is going. We can divide both sides of that equation by I, and we've got an expression which looks remarkably like our first formula. Series resistance is R1 plus R2. Okay, so that's nice, that's easy. Parallel gets a little bit trickier, so let's move on to parallel. Different colour, of course. Here's our parallel circuit, and in this case it's not the voltage that splits, it's the current that splits. So we've got the total voltage, and this is our parallel circuit, so I'll call it VP, the total voltage, and that should be the same as the voltage across R1 and R2, but the total current, IP, this is the current in parallel, is going to be separate here. We're going to have the current through resistor 1 and the current through resistor 2. The current has to split at that node where I'm drawing now. So if we come up with an expression for the total current, we know this. IP, the total current, equals I1 plus I2. And this time I equals V over R is how we're going to use our Ohm's law. So the total current is equal to the total voltage, IVP, over the total resistance, RP. Okay, I equals V over R. And same thing for I1, it'll be the voltage across 1 divided by I equals V over R divided by resistance across R1. But, well, no, we'll finish this first. And I2 is going to be voltage across 2 divided by the resistance 2. Now remember, in parallel, the voltage across R1 is going to be the same as the voltage across R2, which is going to be the same as the supply voltage in this case. So you can see what we've done. It's very similar. This is going to be VP, and this is also going to be VP. So we can divide both sides by VP, cancelling out and leaving our formula for resistance in parallel. That's kind of cool, I reckon. So we've got 2 out of the 3. Now we have to go from the parallel formula to our other formula, which is sort of just a rearrangement of those things. And all we're going to do is cross multiply everything out. So I'll do this in steps first with RP. Multiply both sides by RP. We're going to get RP over RP equals RP over R1 plus RP over R2. Okay, doesn't look like it's helped us just yet, but we'll carry on with this process. Now we want to multiply both sides by R1, so we'll go R1 RP divided by RP equals R1 RP divided by R1 plus R1 RP divided by R2. All these R's are getting a little bit confusing. Okay, so now as you can see, we're going to be able to cancel these out and get rid of the fractions. Let's just carry on for R2 and then we'll do the cancelling. You'll see where this is going. If you get stuck, then you can go back and replay the video. So there's R1 plus R2, R1 R2 RP over RP equals R1 R2 RP over R1 plus R1 R2 RP over R2. Different colour now because I'm going to cancel each of the things. RP cancels with RP, R1 cancels with R1, R2 cancels with R2. And now we're left with R1 R2 equals R2 RP plus R1 RP. Okay, almost there. Now on the right hand side we've got that common RP, so we're going to bring that out the front by itself, and that means we're left in brackets with R2 plus R1, which we could write that, we could swap those two around, it wouldn't matter, so I'm going to rewrite it as R1 plus R2. And if you're following along and you haven't kind of freaked out just yet, you're going to find that we end up with R1 R2 divided by R1 plus R2, so that's the brackets part from the right hand side, equals RP. Because what we've done to get there is just we've divided, we've got R1 R2 there, and we've divided by R1 plus R2 and R1 plus R2, so that this part cancels with this part and we're left with the formula that we were after before, which is our second formula for resistance in parallel. Lots of maths and lots of fun. Yeah, maybe not if you're not that keen, but yeah, I thoroughly enjoy this sort of stuff. It's very cool finding formula.